My name is Iwan from Beurden, and I will be conducting this Exida Certificate Explained webinar. You should be hearing me clearly right now. Audio is provided by the internet. Make sure your speakers are enabled and mute your microphone. Well, we actually have set up this webinar such that it's a one-way audio, so you don't have to mute your microphone. There is a Q&A tab at the top of this live meeting screen, and you can ask questions through that Q&A tab. I will read out those questions, and then I will answer those questions. So if you have anything coming up during the webinar, feel free to chime in and put your Q&A up there. All right. Well, welcome at this webinar, the Exida Certificate Explained. And if you are a frequent visitor to the Exida website, you may have seen that a blog was posted yesterday on the same subject, and the blog actually references to a paper explaining the Exida certificate, all the different sections of the certificate, and what they mean, and this webinar is a logical result of that as well, where we will go through the certificate and explain what each of these sections are. My name is Iwan from Beurden. I'm the Director of Product Development at Exida. That means that I'm responsible for the development and maintenance of our Excellencia software, our SalesNet software, basically the end-user software. But in addition to that, I do many end-user services as well as manufacturer services, and I get involved with the certification activities as well. So I have a pretty broad background when it comes to functional safety, and therefore I'll be conducting this webinar. If you are not that familiar with Exida, we're a consulting, test and assessment agency with offices around the world. We have several main offices in the U.S., Mexico, Canada on the Western Hemisphere. Then we have Germany, in Switzerland, Singapore, and South Africa are the main offices on the Eastern Hemisphere. We have several regional offices, one, for example, in the Houston region. So we have different offices around the world, and our main focus is functional safety, cybersecurity, and alarm management. Our product and service categories, we have consulting in process safety, primarily 61511, control system security and alarm rationalization. We do the product certification for functional safety per IEC 61508. That is what we'll primarily be talking about today. But we also do cybersecurity certification, different training classes on process safety, control system security, alarm rationalization, either online, on-site, whatever works best for you. Some are open enrollment. Then we have a variety of engineering tools, like the Excellencia Safety Lifecycle tool, with its sub-tools like FAX and Silalam, Select, LOPA-X, a tool that's going to be released shortly. We have the SalesNet software, various reference documents, textbooks, as well as data books. You may be familiar with the Safety Equipment Reliability Handbook. And then we do the professional certification with the CFSE, CFSP programs that the CFSE Governance Board is running. All right, so when we are talking about the Exida certificate, the easiest way to do that is just splitting that certificate up into a couple of pieces and then talk about each piece individually. And if we look at an Exida certificate, you will see that it has two sides, a front and a back, page 1, page 2, and we can distinguish a total of 4 different areas. On the front, first page, we have on the left-hand side a scope, assessment level, a revision and expiration area. Then we have a main conformity declaration on the right-hand side. And then on the back of the certificate, or page 2, on the left-hand side, we have the certificate template. And on the right-hand side, we have failure rate information and support documentation. And I will go through each of these sections and explain what the different pieces of information on those sections mean. But these are the 4 that we will be looking at. So let's start with the scope, the assessment level, revision, and expiration section. At the bottom of that area on the certificate, you will find this ANSI logo. ANSI is the American National Standards Institute, and ANSI has accredited the exida assessment program, and has found that our way we run our certification program meets the requirements of a product certification program, and our unique identifier is number 1004. And any certificate that we issue that is in compliance with our accredited assessment program by ANSI will have that logo on the certificate. And this is something that's relatively new. We've been accredited for a couple of years now, but you'll see that there are some older certificates on the market that don't have this logo yet, and then the newer certificates do have the logo. But it's kind of important to realize what ANSI Accredited Assessment Program means. ANSI is part of the International Accreditation Forum, which is an organization that sets up rules for accreditation. And any country that has a organization that is associated with the International Accreditation Forum will accept the certificates that are created as part of in this case, ANSI Accredited Assessment Program. So the exida certificates, because they are part of an ANSI Accredited Assessment Program, are automatically accepted in the United Kingdom by the United Kingdom Accreditation Service, in the Netherlands by the Raad voor Accreditatie, in Germany by the Deutsche Akkreditierungsstelle, in Singapore for the Singapore Accreditation Council, in Australia and New Zealand for the Joint Accreditation System of Australia and New Zealand, and many, many more. These are just a couple that I wanted to highlight. So that's what the ANSI logo means on our certificates. All right, the next area on that left-hand side of the certificate is the scope and assessment level, and you'll see a little text that says the manufacturer is allowed to use the mark, and then you see a little logo that is pointed out here on the slide, and that logo is something that the manufacturer can use on their products. They can stamp it on their products. They can use it in their literature, provided that the product, of course, is certified. And the certification mark documents two things. It documents the scope as well as the achievement level. And in this example here, we see that this certification mark is per IEC 61508, and that's kind of the focus of this webinar today. And that the level is SIL3 capable, and we will talk about what SIL3 capable means in just a bit. But that's the standard, the scope, and the assessment level are embedded in that accreditation mark. And this product or a product that has a certificate with this particular logo, that simply means that the product passed the exida 61508 assessment scheme up to a SIL3 capability level. We'll talk about what that capability level means in just a bit. Then the last piece of information on that left-hand side of the front page of the certificate are the revision and expiration. Certificates, every now and then get updated. Maybe sometimes the name of a product changes, or there are revisions to a product, and instead of doing a complete new certification of the new product, we do a revision or modification review of the product, and we end up with a new revision of the certificate. So the certificate can have multiple versions. The latest is always available on our website, and the certificate version and the date issued are shown on the front page of that certificate. Now there's also a valid until date, and the valid until date obviously explains when the certificate will expire. And why do we have that on there? And sometimes manufacturers prefer to not see it on there because obviously when it expires they will have to renew. But the exida IEC 61508 assessment scheme allows manufacturers to make modifications to their products, provided that they use the development process and modification process that we audited and assessed during the original product assessment. So manufacturers are required to have a very detailed modification development process, And as long as they follow that modification development process, we allow them to make changes to their product. When the certificate expires, manufacturer will, of course, have to renew their certificate, and that renewal triggers a surveillance audit. And in that surveillance audit, we will look at all the changes that have been made to the product. And of course, the manufacturer will have to show that all the changes were made in accordance to the development/modification process that was assessed during the original assessment. If they have not followed that modification process, if they made changes to the product that do not comply with the original certification, we will withdraw the certificate from the market. We will remove it from our website. And as part of our assessment scheme, we at that point also need to withdraw all other certificates from that same manufacturer. So all other certificates that we issue to the same manufacturer. In addition to that, we need to issue a news release that those certificates are no longer valid and people should not, consider the product certified to IEC 61508. So that could have a significant impact just from a marketing perspective on a manufacturer if they do not follow their development process when they make any modifications. Now, in reality, majority of our customers or of the manufacturers that we have, whose products we certify, they tend to contact us just before they make any significant changes, just to make sure that everything is still lined up. So manufacturers don't go willy-nilly making changes to products. So that's something you should not be too afraid of. But if after a certain period of time, after the certificate expires, we come to the conclusion that, hey, you have not followed your modification process, you have not met the requirements that we laid out, that we agreed on, then we need to withdraw that certificate from the market. If there is no expiration date on the certificate, that automatically means that the manufacturer is not allowed to make any changes. So the product can only that particular hardware and software version that we looked at during the assessment is certified. Any modification, any deviation from that product, from those software or hardware versions, would mean that we would need to go through a full recertification. Another way to look at that, the manufacturer does not have an adequate modification process to make changes to the product. It doesn't really happen. I can't really think of any certificate we've issued without a expiration date. The only scenario I can come up with is that a particular product has been developed, and the company that has developed it goes bankrupt, and there's no future development to that product, and someone goes through the effort to get the existing product certified. That's the only logical scenario I can come up with. So that's what the revision and expiration mean. So that's the first part on the front page. The second part, the main conformity declaration, that's where most of the meat is of the certificate. At the top of the certificate, you'll find the unique identifier, a 3-letter combination followed by 7 numbers, the letter C for certificate, and 3-number identifier. The first 3 letters and 7 numbers could be the same for several certificates or for the same manufacturer. When we evaluate the same product line, the 3-number identifier will then be the unique certificate ID for each of the products that were certified. So that's the unique identifier, and with that we can always look up all the information associated with that particular assessment. Then the next step is, or the next part on the front of that certificate is the product and manufacturer that were evaluated as part of the assessment. And it's kind of a combination of the two. It's not just the product, it's the product and manufacturer when we do these 61508 assessments. And sometimes we see products that are manufactured by a single manufacturer but sold by different manufacturers, OEM. The fact that a product is certified for manufacturer A does not necessarily mean that it's also certified for manufacturer B. There are several aspects to a development process, and this kind of extends a little bit beyond the development process, goes more to a quality system, where we look at the way that the manufacturer handles field returns, the way that the customers are notified, and obviously that could be different for manufacturer A compared to manufacturer B. The next step is the standards and assessment levels. If we talk about IEC 61508, then what you'll see is that we certify to IEC 61508 2010, the second edition of the standard, parts 1 through 7, which are all relevant for the IEC 61508 assessment scheme that we have here at Exida. You could argue that parts 5, 6, and 7 are informative, but we still consider them in the assessment. When we look at the hardware and software development of a product, there are certain techniques and measures that you need to implement for different SIL levels, and part 5, 6, and 7, particularly part 7, has a lot of explanation on the different techniques and measures that you can implement. And now, when you are requiring someone to implement a certain technique and measure, it's always good to look at the explanation and background information. So those parts are still considered in the assessment. If we have a non-software based product, then we still include part 3 of 61508. Part 3 talks about the software development. However, a simple argument at that point is made that software development requirements are not applicable because the product doesn't have any software. But in the end, we still certify to the entire standard. 61508 contains two main requirements: development process quality system requirements and product-specific performance requirements. So let's have a look at these. First, if we look at the development process and quality system requirements, then what we see is that depending on the SIL level that you want to be certified for, the requirements may differ. And to be a little bit more specific, the higher the SIL level that you want to achieve, typically the more stringent the requirements become. So as an example, when it comes to the concept of software architecture design, for SIL 1, fault detection is not required. For SIL 2, it's recommended, and for SIL 3, it's highly recommended. In other words, if you want to achieve SIL 3, you need to implement the software architecture design fault detection concept. For SIL 1, you would not. So the higher the SIL level, the more stringent the requirements are. So we express this capability of the development process quality system, we express that in terminology that we call systematic capability. Well, we call it, that's also what the standard calls it. And it basically indicates the level of the development process that we consider. And if a product has a systematic capability of SIL 3, then it means simply that the development process, the quality system that the manufacturer uses, meets the SIL 3 requirements. And therefore, the product can be used in SIL 3 applications. If the product systematic capability is SIL 2, the development process meets the requirements of SIL 2, the product can only be used in SIL 2 applications. This does not say anything about if the product can be used non-redundant in SIL 3 applications. It only says something about the ability of that product to be used in SIL 3 level applications. So if I buy a valve, and that valve is SIL 3 capable, most likely I'll have to put in redundant valves just to meet my probability of failure on demand requirements. But I can use this valve in a SIL 3 application. If I buy a SIL 2 certified transmitter with no other information than it's SIL 2 capable, that means that that transmitter can be used in SIL 2 applications. And hardware fault tolerance requirements may say, hey, if you use it in a hardware fault tolerance of 1 or a 1 and a 2 type voting architecture, you can go up to SIL 3 from a probability of failure hardware fault tolerance perspective. The fact that the systematic capability is limited to SIL 2 means that you cannot use it in a SIL 3 application in a redundant fashion. It is limited to SIL 2. So the majority of the manufacturers tend to shoot for the SIL 3 level assessment simply because if there's just one function in your plant that is SIL 3, then at least that product qualifies for that function. Again, it does not mean that the product can be used without any redundancy. It simply means that the development process and the quality system that the manufacturer uses is capable of achieving SIL 3. The second portion is the product-specific performance requirements, and that's typically expressed in the random capability. But the product-specific performance requirements build up out of two unique items: a probability of failure for an entire safety instrument of function, and the minimum hardware fault tolerance for an element. And when we look at the probability of failure, then we cannot calculate the probability of failure for the entire safety instrument of function when we look at a single product. We cannot calculate what the SIL level is achieved based on the probability of failure unless we have the entire safety instrument of function. But the entire safety instrument of function is going to consist of many different components. So the exida certificate simply states that the probability of failure must be verified for each application. We cannot tell you up to what SIL level this product will be able to be used because we don't know how often you do your proof tests, we don't know how you do your proof tests, we don't know what your maintenance capability is, we don't know what redundancy scheme you use, we don't know, and so on. So from an exida assessment perspective, we can only tell you, you need to evaluate your probability of failure requirements as part of the entire SIF. The second portion is the minimum element hardware fault tolerance, and it can be specified only if the product constitutes a complete element, and an element is defined in the standard as a combination of components that perform a safety function. An actuator, for example, is a component, but it's not an element. It's a component within an element, and finite element to be precise. We would need a valve, we would need a solenoid in order to have this actuator perform a safety instrument of function. So in case of an actuator, we would not conclude a architecture constrained safety integrity level or safety integrity level based on minimum hardware fault tolerance. Okay, I see here someone has a question. Just type your question in the Q&A, and I will read the question and I will answer it. That's the easiest way to do this. So just type it in the Q&A. When we look at a transmitter can be a complete element. In that case, we will specify a architecture constrained SIL level. So so depending on the type of equipment, we can specify up to what SIL level product can be used in. The certificate will explain if the product under consideration is a type A or a type B equipment type. Type A means that all failure modes of all components are well defined, that the failure behavior of the product can be completely predicted, and that there's adequate field failure information to make a proven use claim. If that's not the case, if you don't meet one of the three, then you're automatically a type B. As a rule of thumb, anything that uses a microprocessor or custom ASIC, application-specific integrated circuit, are typically a type B. Devices that don't use that, like a relay, a switch, they tend to be type A. So transmitters, logic solvers tend to be type B. Here we have a question. Okay, there's a question here on Route 1H and 2H. We're going to get to that in just a bit. So that's something that we list on the certificate. Then we specify the SIL based on architecture constraints, based on minimum hardware fault tolerance for a hardware fault tolerance equal to 0 and a hardware fault tolerance equal to 1. So what if the hardware fault tolerance? What if you have a redundant architecture, one of the two of the three, that's a hardware fault tolerance of 1? and what if you have no redundant architecture? Up to what SIL level can you use a specific product? And then we list the certificate, or the certificate indicates what minimum hardware fault tolerance method we apply. If we apply the method as specified in Route 1H or in Route 2H, and this is where the question was in what's the difference between the two. Route 1H is basically the method that was also defined in the first edition of IEC 61508. That is the scenario where you will calculate a safe failure fraction and where you will look at a table for Type A and Type B equipment and then determine your hardware fault tolerance, and the combination of safe failure fraction, hardware fault tolerance, Type A, Type B, will dictate up to what SIL level you can use a particular configuration. So for example, if you have a Type B equipment with a safe failure fraction of 60 to 90%, you will be able to use that in a SIL 1 application if you have no redundancy, and a SIL 2 application if you have one level of redundancy, one level of hardware fault tolerance. So that's the Route 1H. The Route 2H addresses the confidence level that you have in the failure rate information for a particular device, and it requires a certain number of recorded operating experience, operating hours, a number of a maximum number of failures. And if you have a certain level of confidence, and from the top of my head that's 90% confidence interval on that data, then instead of calculating the safe failure fraction, instead of looking at the tables for Type A and Type B, you use a table that is similar to the IEC 61511 table, where for field equipment there's just SIL 1 no redundancy, SIL 2 1 level of redundancy, SIL 3 2 levels of redundancy. There's something similar to that table that would then apply. So that's the difference between Route 1H and 2H. 1H, think of safe failure fraction tables for Type A and Type B. 2H, think of the quality of the failure rate information that you have, and based on that you have certain levels of redundancy requirements. So those are listed on the certificate. But again, keep in mind, this random capability goes hand in hand with the systematic capability on the previous slide. The systematic capability will determine up to what SIL level you can use a product based on the development process that was being used. This random capability obviously looks at the probability of failure, but then looks at the minimum hardware fault tolerance requirements. If you put in a lot of redundancy and you say, well, I can use this, let's say, poorly developed product in a SIL 3 application, and your systematic capability is going to say, hey, hold it, that doesn't apply here. You will have to, you're limited to maybe SIL 2. All right, so if we continue on that main conformity declaration section of the certificate, the next area that we see is the safety function and application restrictions. And what we need to document on our certificate is the restrictions of the certificate, as well as the safety function that we evaluated. And if you look, for example, at a shutoff valve, most likely for functional safety, the on-off functionality of the device was certified. If you want to use that valve in a control function application, there's nothing that will say, hey, you cannot use that valve in a control function application, except that the certificate, the certification at that point is no longer valid. You need to use that product within the safety function as evaluated as part of the certification process. If you use it outside of that safety function, that sort of certification is no longer valid. Another example would be a transmitter where the output 4 to 20 milliamps are a part of the certification evaluation, and the HART protocol that can be used to add additional information on that analog output has not been considered. At that point, only the 4 to 20 milliamp output would be considered part of the safety function. There's nothing that says you shouldn't be using the hard communication, but if you want to base your voting, etc., on the hard communication, then you're outside of the certification scope. There's another question here. I have a question here. That's a good one. If the random, so that goes back to the previous slide. Let me just go back to that previous slide so that we were in the same scope. If the random capability of Route 2H are better than those of Route 1H, why would an end user bother to use the Route 1H values? I have no idea why they would. Obviously, if you have adequate information to support the Route 2H conclusion, then that's what you should go with. That will probably give you better design overall. We see similar items. Similar items in IEC 61511, where 61511 requires initially no redundancy for SIL 1, but then when you read clause 11.4.3 of 61511, it says that if the dominant failure mode is not to the safe state or dangerous failures are not detected, you need to increase that minimum hardware fault tolerance requirement by 1. And that basically means for finer elements where the dominant failure mode tends to be dangerous and undetected, that simply means that for fine elements, you need to increase the minimum hardware fault tolerance by 1, and you get that you need redundancy for SIL 1 applications. There's very few users that think that that's reasonable, but that's what the standard concludes. Now, there's also a clause in 61511, which is clause 11.4.5, that allows you to deviate from 61511 as long as you are compliant with IEC 61508. And so many of our customers will actually use the architecture constraints that are defined in IEC 61508, even though they're end users and they have the IEC 61511 standard that they want to be compliant with. It's still within the scope of the standard, but it's just a better way to get credit for good engineering practices. Same thing, if you have adequate data, one of the reasons people came up with the architecture constraints was to avoid, ridiculously low failure rates and ridiculously low proof test intervals being used in the probabilistic calculations. So if you have adequate information, then hey, that's definitely the way to go forward. There's another question here. So the Route 2H is based on failure data, on the confidence level that you have on the field failure data. And within Exida, we have a tremendous amount of field failure data, hundreds of billions of hours of operating experience. So when we evaluate a product that where the individual components, we conclude that there is adequate data to claim Route 2H, and you need to be able to do that for each and every single one of those components, then we will conclude that that product is capable of achieving Route 2H compliance. At that point, we do not leave it up to the end user to gather that field failure information simply because we already have it. If there are components in there that do not have the adequate field failure experience, then it will be up to the end user to support that. And the majority of end users tend to not have sufficient amount of operating experience, documented operating experience to support that. But that will be the next step, yeah. All right, back to the safety function and application restrictions here. One more question here. So Route 2H is based on use, so is the information used based on specific product or general classification of products? It's not necessarily general classification of product. We actually look at it more on the component level. So we go to the nuts and bolts levels and look at if there are if parts like that have adequate field failure experience. All right, back to the safety function application restrictions. So we need to understand that the certificate is only valid when that product is used within a certain safety function and within certain application restrictions. And those restrictions could, for example, be environmental limits, certain temperature limits, shock vibration, and so on. Those environmental limits or those application-specific restrictions are documented in the product safety manual. And the safety manual is an integral part of our assessments, and I'll talk about that in a little bit as to where you will find that information. But any restriction, and there could be environmental like here, or if you have a logic solver, maybe your AND and OR blocks and your function blocks are part of the certification. Your add and subtract blocks are part of your certification, but some complex logic block may not be part of the certification. So the safety manual will list all the components that are part of the certification, or all the options that are part of the certification, and also how you need to use the product. So sometimes we have to deal with certain grounding requirements. You need to follow those grounding requirements before you actually can say that you are using the product within the certification that it was looked at. It's key to look at that safety manual. You need to understand how you need to use that product before you actually buy the product. So I would always urge you to talk to the manufacturer, get that safety manual before you actually purchase the product. Then at the bottom of that main conformity declaration section, you'll find two signatures. A signature by an evaluating assessor and a certificate by a certifying assessor. And our assessment scheme requires that there are two independent assessors to evaluate a product's compliance. The evaluating assessor is the one that performs the majority of the activities. That person may be doing a detailed product evaluation through a failure mode effect and diagnostic analysis. That person may be doing a software architecture evaluation by means of a software criticality analysis. He may be involved in the software HAZOP, where you look at the safety measures implemented and in the software process or the software development of the product. That evaluating assessor will also review all the compliance arguments that a manufacturer may have, why they meet the assessment scheme requirements. So why are they compliant with IEC 61508? Why, now, for example, if we go back to that software design architecture fault detection, for SIL 3, that was highly recommended. Give a good argument, show evidence why you meet that particular requirement to say, yes, your development process meets the requirements of SIL 3. The result of all that is what we call a safety case, and in our case, we document that in a database where we have all the requirements. We document all the arguments why requirements are met, and then we also embed the evidence documents why that support the arguments in that safety case, and that is then the solid solid documentation why a product meets the requirements of IEC 61508. When the evaluating assessor is done, the certifying assessor will establish an independent review of the product, of the manufacturer's development process, and of the safety case that was created by the evaluating assessor. And though both are employed by Exida, they are two distinct different persons, and they both have the authority to basically refuse to put their signature on a certificate. If they think that if that product is not capable or does not meet the requirements of 61508, they can refuse to put their signatures on there. That's a power that they have. They are independent of each other, and that sometimes when a certifying assessor goes to the manufacturer, goes to site to do the final audit, the final assessment, he may show up and say, okay, what's the product that we're looking at? And of course, people tend to be a little bit more aware of what they're doing than that example. But it could be that extreme where the certifying assessor has simply not been involved with any aspect of the assessment project up to that point. So that's the assessors area. So that's basically complete. It completes the front of the certificate, the page 1 of the certificate. So let's look at the back of the certificate. One of the things we see there is the template, the certificate template. Our assessment scheme is continuously evaluated. We get feedback from end users. We get feedback from manufacturers. Every now and then, our own assessors say, hey, there's room for improvement. Hey, we need to do this better, or we need to do that better. We need to communicate this better, and so on. And as the assessment scheme is continuously evaluating, the certificate that is the result of the assessment may change. And that certificate template that we use for each assessment has a unique identifier, and that could differ, I should say, from one certificate to the next. And in this particular case, the template 002 version 3 revision 3-3 template 002 from the top of my head is type A devices, still 3 capable type A devices. That's a certificate template that we use for those types of piece of equipment. And you may see, let's say, 2 ball valves, both certified by Exida, but the certificates may look different. And the simple explanation for that is they may be different certificate templates. Look at that certificate template number. That would explain why they are different. So the last portion of the certificate, the right-hand side of the back page, or this page 2, talks about the failure rates and support documentation. There's a couple of things at the top of this portion of the certificate that are basically repeats of the first page, like the certificate identification, the assessment levels. But the main piece of information here is the failure rates and the supporting documents. And when we look at the failure rates, well, one of the things that you will see is we publish failure rates. We do not publish a probability of failure in the month. Why don't we publish a probability of failure in the month? Because it depends on many parameters. Approved test interval, approved test coverage, emission time, and maintenance capability, and many, many, many more. If we would publish a probability of failure in the month, we would imply a mandatory test interval. We would imply mandatory test procedures. We don't know how often you plan to test your transmitters or your valves. We don't know what type of test you're doing. If for your valves, do you do just a full stroke? Do you do a full stroke with a leak test? Do you do a full stroke with a leak test? And are you looking at a valve signature? If we would publish a probability of failure number, we would have made those assumptions, and you would need to know what those assumptions are. So in our opinion, the final probability of failure in the month can only be determined by the end user. And in order for the end user to do that, he needs failure rates. So we publish the failure rates. If you ever get a certificate with a probability of failure number on it, you will have to ask what the assumptions were. Did they assume redundancy? What's the mean time to repair that was assumed? How often was the proof test, and so on. So that's just too much information or too many variables that could impact that probability of failure number, that we just simply said, you know what, failure rates is the way to go. And the failure rates that we publish are published in a safe or dangerous and detected or undetected category. And the detailed definitions of these are documented in the assessment report. So if you go to our assessment reports, it will explain exactly what the safe state is, what the dangerous state is, and so on. For final elements, we always publish 2 sets of data. Data when the product is used under normal circumstances, and the data that will be applicable if that product is used with the partial stroke test. So what diagnostic coverage can you give to that particular product when a partial stroke test is performed? And I have an example in a little bit, and I'll address that there again. So then we have the support documentation at the bottom of the certificate. So that will be right around this area here. And it will reference the assessment report. It will reference the Exida assessment report that we wrote as part of the assessment process for this particular product. And it will also reference the safety manual. The safety manual that documents the restrictions that you need to follow when you use that particular product. our assessment scheme requires that we publish the certificate and the assessment report on the Exida website. And we do that on the Safety Automation Equipment list. So you can go online to our website and see certificates and assessment reports for the different products that we certify. The safety manual is issued by the manufacturer. So the safety manual is a document that you will need to get from the manufacturer. It is an integral part of the assessment. We review that document several times to make sure that all the restrictions are clearly communicated to the user. But that's under control by the manufacturer, so that's where you would need to get that particular document. So let's try and interpret some of the certificates. And I think there are a couple of manufacturers that have dialed in. Let me just tell you, I just randomly picked certificates. I'm not favoring anybody. I just grabbed something from our database of certificates, and I wanted a pressure transmitter, and this is the one that I picked. And you will see that this particular certificate, it looks a little bit different than what I was just talking about. I mean, it has the mark that the manufacturer can use. This doesn't have the ANSI logo yet. To be precise, this was issued in 2012. That may be just around the time that we got our ANSI accreditation. So that may be the reason why this particular certificate doesn't have the ANSI logo yet on the certificate. You also see that the reports are the evidence document or supporting documents are listed on the front of the certificate instead of on the back. So that's also something that as time evolved, we got two different way to handle things. The assessment in this case apparently is valid until December of 2013. So I picked the certificate that actually already expired. You see template information on the backhand side. You see failure rates. And then you see the overall product assessment levels and the assessors, including the safety function. So in this case, the transmitter is only for the 20 milliamp 2-wire interface. That is part of the scope. So this particular device can do hard communication, but that hard communication has been determined interference-free or feedback immune, and we have not considered the hard signal as part of the safety function. Then we have a digital valve positioner here, and again, I randomly picked something, and this certificate actually matches what I was just showing you. It has the ANSI logo here, including the 1004 identifier for the Exida accreditation scheme. It shows the valid until and the revision date, the mark that the manufacturer can use. Again, 61508, SIL 3 capable. Can the digital valve positioner be used non-redundant in SIL 3 functions? Most likely not. I haven't run the calculations. Most likely I will need redundancy, but I can use it in SIL 3 level applications because the development process and the quality system that the manufacturer uses meets the requirements of SIL 3. So we have the specific product identifier here, the manufacturer, the standards and assessment levels. We have the safety function defined. On the back we have the failure rates, and we have the supporting documents. So here you see the safety manual, you see the assessment report, the unique identifier of the certificate. So this one looks just like something I just described. Now, as I mentioned before, for final elements, we tend to list two sets of failure rates: normal failures, meaning the product is only used for, let's say on-off, and then with partial stroking failures, where every now and then you perform a partial stroke of the device. The definition of a partial stroke as to how much percentage closure you want to achieve, that is all defined in the assessment report. There's an assumption stated there. And in this case, you see the digital valve positioner, and you say, well, I don't know what the actuator is. I don't know what the valve is. How can you put in a coverage factor? How can you claim that the failure rates are different for partial stroking? Well, the failure rates here are only valid for this product. So in this particular case, if you do a partial stroke test, certain functionality is exercised in this product, and you can detect certain failures. So some of the failures that were initially undetected, safe undetected or dangerous undetected, now become detected, safe detected or dangerous detected. But it only talks about the failure rates applicable to this product. This product obviously doesn't know anything about the actuator it's connected to, doesn't know anything about the valve that the actuator is connected to. So for those particular products, you would have to get the partial stroke information for the individual certificates of those products. So that's what that means here. With partial stroke, it doesn't mean that the overall coverage factor is a certain percentage for everything in that final element. It only means that for this particular product, these are the failures that you will detect. And how do we know that? Because we go into that product, we evaluate the product in detail, look at each and every of the components, and then we look at what if a partial stroke test happens. Will we detect this particular product failure, this particular component failure? And if so, then obviously it's a detected failure. If not, it remains an undetected failure. A ball valve here, and this again is an example of an older certificate. The reports on the front here, the failure rates are in the back. You will see a full stroke application where only on-off is basically being used, an application where tight shut-off is required. Doesn't mean that the valve cannot do tight shut-off in the first case, full stroke. It just simply means the tight shut-off is not required as part of your safety function. You only need to achieve a full stroke to achieve the safe state. In the second example here, you will require tight shut-off to go to the safe state. And the third one here, open on trip, and then the same set of applications with partial stroke data. Again, the product name, the manufacturer, the certificate number, the systematic capability. In this case, apparently the manufacturer is also capable of achieving SIL 3 from a development process and quality system perspective. Doesn't mean that the product can be used in SIL 3 without any redundancy. Most likely you will need redundancy. And that's an example of this particular case, a ball valve certificate. Oops. So one of the items that has come to our attention is how do, as an end user, when you get these certificates, how do you determine the validity of these certificates? And you know, our certification program is pretty successful. Our certificates are recognized around the world, and many will see them superior to any other certification that's out there. End users recognize our application knowledge and you know, appreciate that experience that we have. We, for example, will not issue a certificate where, and you can look in our blog history, a couple of blogs that I posted, may have been a year ago already, but you know, a assessment, apparently another company's assessment showed that there were safe failure rates for a ball valve that was not connected to anything. I don't see how that valve can move, transition to the safe state without something being connected to it, so that simply doesn't make sense. Or similarly, there was an actuator, spring return actuator. Normal circumstances, you know, you put air pressure on the actuator, spring will compress. If you remove the air pressure, the spring will extend, and you will, you will operate the valve. And in that particular example, the actuator did not have any safe failures, and you know, just a simple seat leakage could cause the actuator to go to the safe state. So it doesn't make sense that there were no safe failures. So we see that many end users recognize that we understand how these products are being used in the field. We have a set of hard hats here with I don't know how many scratches, because we climb on top of reactors, on top of gas turbines and so on, and to do inspections, and we see how these products are being used in the field. A lot of the manufacturers realize that, you know, our assessment is not a rubber stamp. They may show up and think their product is perfect, and their assessment and their development process is perfect, but there's still effort involved in getting their development process evaluated and getting the product evaluated. And some of the manufacturers, you know, tend to challenge us to make it even more stricter or more stringent for assessments. But in general, manufacturers appreciate that we are trying to make their products functionally safer. We try to add value to their products. Now, not all manufacturers or products will pass, and it's unfortunate to see that sometimes you do an initial assessment of a product and you find gaps in the development process, or you find that the product itself is not really compliant with requirements of the standard, and you issue a gap analysis and you indicate, hey, these are the things that need to be improved in order for your product to be certified to 615 rate, and the company in question decided that they didn't want to go down that path, so they just simply self-certified and issued a certificate signed by themselves that their product was capable of, let's say, SIL 2 for IEC 61508. That's of course very sad. Unfortunately, we cannot divulge that information because we signed non-disclosure agreements. But that's pretty. Yeah, you could question morality there. But no, not all manufacturers will have their products pass, and then sometimes there's a lot of effort involved, and that sometimes takes quite some time. The downside of success is that counterfeit certificates are showing up on the market, and that's of course an issue, because a manufacturer or a sales rep or whoever is creating these counterfeit certificates will suggest that a product is certified by Exida up to a certain SIL level, and yeah, they simply are not. And some of these companies, they're I don't say big name, well, they're pretty big name companies. And you wouldn't expect these companies to do that kind of thing. And I'm not saying that they are. It may be a local sales rep. It may be someone just enjoying the life of Photoshop. I don't know. But these certificates, these counterfeits, have been found on the market, and I'm just posting them here as an example. But how, as an end user, do you know that this certificate is valid or is not valid? The newer ones, this one here even has the ANSI logo. The newer ones, of course, the Photoshop capabilities of people tend to increase. They look pretty good, and I recognize some signatures. So obviously they had a copy of a real certificate, and they were just making changes to them. So as an end user, what can you do? As I said, as part of our assessment scheme, we are required to publish all certificates and assessment reports. So how do you determine the certificate authenticity? You simply go to our website, www.exida.com, go to the Safety Automation Equipment list, and you find that product on that website. You can search, and you can just simply type in, I want to find product A from manufacturer B, and you can type in that name, and the list will spit out all the certificates that we've made for that manufacturer, or all the certificates that have the same for particular product series, and so on. And you can actually verify that a certificate is valid. So the authenticity is something that, as an end user, you would have to actively go in and unfortunately actively go in and verify that they are valid. Unfortunately, there are people in the world that whose products do not meet the requirements of 61508 per the Exida assessment scheme, and they try to find their way to the market this way. So look at the exida.com SAL Safety Automation Equipment list to find these items and make sure that your certificates are indeed authentic. We try to through our blogs, through newsletters, we try to inform people that there are counterfeits on the market. So that's just a heads up. Make sure that you're dealing with a real one. All right. Hey, any questions? Are there any questions aspects that I may not have answered yet? As you may know, this is the second installment of the webinar. We do one in the morning, we do one in the afternoon, and a lot of the questions that I get in the morning, I tend to incorporate in the webinar in the afternoon. So theoretically, you guys get a better quality webinar than the morning guys. But if there are any other questions, please feel free to ask them. Use the Q&A. If not, then thank you for dialing in. I look at the time here and I see that I've been able to talk for an hour. So if you want to head home or have other things to do, I fully understand. But we will start stopping the recording. The recording will be made available to you probably tomorrow. A copy of the slides will also be issued to you. Our webinar team will take care of that. So if there are any other questions, again, the Q&A. If not, send an email to info@exida.com, info@exida.com, and we will answer those questions as they come in. And you also have the ability to, I think you have the ability to respond to some of the blog posts, and then the support staff is usually making sure that we get the correct information out there as soon as possible. I see a question coming up, or at least it looks like someone's going to be typing a question shortly. Just type that question in the Q&A, and I will be able to answer. If not, then, well, thank you for dialing in. I hope this was very informative to you. Again, any further questions, send an email to info@exida.com, and we will go from there. So thank you for dialing in, and take care.